Courses in the cement industry. Present to you. In this course will be explained Rotary Kiln drives. Part 1. Covered in this section are the two most common types of gear mounting arrangements, their pros and cons, and a recommended inspection program. Types of lubrication are discussed as well. Introduction. No discussion of troubleshooting rotary kilns, dryers, and other rotary equipment would be complete without the inclusion of the special problems of gears, pinions, and drivetrains. Understanding the mechanical function of these parts, and the differences in their design will help to focus on areas that may cause problems in the future, or may already be causing problems. The alignment and mesh of the gear and pinion, the lubrication that is used, and the other components involved in the drivetrain, are all areas that should be carefully inspected on a regular schedule. Covered in this section are the two most common types of gear mounting arrangements, their pros and cons, and a recommended inspection program. Characteristics, advantages, and disadvantages of different types of lubrication are discussed as well. Rotary kiln drives. Divided into 1. Girth gear and pinion drive. Two. Rollers friction drive. Rotary kiln drive systems. Girth gear and pinion drive. Divided into 1. Mechanical drive. 2. Hydraulic drive. Friction drive, through support rollers. Divided into 1. Mechanical drive. 2. Hydraulic drive. Rotary kiln gear drive. The forces from the drive unit are transmitted to the rotary kiln shell via the girth gear. Rotary kiln drive girth gear. Girth gear. 1. Most sensitive item on the rotary kiln. 2. Expensive part. 3. Manufacturing is long, 1 year. 4. It is in general cast, then machined. 5. Teeth repairs are generally not possible, break quickly. 6. Lifetime approximate, 10 years per face. Important note. Girth gear must be watched very often to ensure long lifetime. Pinion. Rotary kiln can have a single pinion or a dual pinion drive. Important note. For large rotary kilns, dual drive is preferred. It keeps width of gear down. In this picture it is explained. Single pinion drive. In this picture it is explained. Dual pinion drive. Main components rotary kiln gear drive. 1. Girth gear. 2. Pinion. 3. Torsion shaft. 4. Main gearbox. 5. Main motor. 6. One-way clutch. 7. Inching drive reducer. 8. Backstop. 9. Inching drive motor. Main components rotary kiln gear drive, for other design. 1. Girth gear. 2. Pinion. 3. Coupling. 4. Main gearbox. 5. Main motor. 6. Cooling unit. 7. Emergency power generator, in general, or diesel engine. See this video about main components rotary kiln gear drive. See this video about main components rotary kiln gear drive, for other design. Girth gear mounting methods. 1. Flange-mounted. 2. Spring-mounted. Girth gear mounting methods. 1. Girth gear flange type. Main components of girth gear flange type. 1. Bridge support. 2. Bridge plate. 3 and 4. Plate bolts. 5. Girth gear. 6. Heat shield. Flange-mounted gears. Most flange-mounted gears are found on older kilns, or on equipment such as dryers, and coolers that operate in a lower temperature range. They are generally constructed in 2 or 6 sections, and the mounting flange is typically welded directly to the shell. It is easy to reverse the gear to maximize service life, if the flange is still rotating true, and in good condition. However, a common problem encountered when attempting to reverse, or install a new flange-mounted gear, is that over time the shell has incurred thermal damage, because of refractory failures. Depending upon the location of this damage, it can create a significant amount of runout in the shell, where the gear is mounted. If this is the case, the mounting flange must be cut loose, and remounted, or a new flange must be installed. In some cases, additional centering of the gear can be accomplished by pre-drilling the mounting holes in either the gear or the flange. This can also be limited by the way the flange was originally machined. A careful inspection should be made for these factors and consideration given prior to planning any gear reversal projects. Girth gear mounting methods. 2. Spring plate type. Spring plates prevent thermal expansion of shell, getting transferred to the gear, whose axis remains the same, and hence clearances between gear and pinion do not get affected in hot running conditions. Spring plates permit expansion of shell, without disturbing center distance between gear and pinion. Girth gear, spring plate design. Spring plate type, divided into 1. Gear rim spring, V-shape. 2. Gear rim spring, standard. In this picture it is explained. Gear rim spring, V-shape. In this picture it is explained. Gear rim spring, standard. Girth gear, spring plate design. Girth gear mounted on spring plates, attached to rotary kill shell. Spring plates installed by 1. Welding, in the rotary kill shell. 2. Installed with bolts in girth gear. We flowing with us. Spring plates installed. In this picture it is explained. Girth gear installed. Spring-mounted gears. Spring-mounted gears are the predominant type of girth gear arrangement for rotary kilns. There are two basic variations, the most common, the tangential spring, and the horizontal spring bar. The positive aspect of these designs is that they allow the rotary kill shell to expand without restriction, unlike the flange-mounted gear. When installing a new gear, or reversing an existing gear, it is always advisable to replace the spring plates and the pins. The plates are subjected to thousands of cycles over the years, and as such there is always concern for fatigue failure. Also, since the springs are welded to the shell, they are usually compromised to some degree during the removal process. Trying to reuse the spring plates can greatly inhibit the ability to achieve acceptable gear runouts. Torsion shaft. A torsion shaft is almost always used between pinion and gearbox. The most important features: 1. To prevent overload. 2. To take misalignment. In this picture it is explained. Membrane coupling, tolerances. Hydraulic drive for gear and pinion. The hydraulic motor is mounted directly onto the pinion drive shaft. As there are no high-speed elements, which need reducing in speed, the hydraulic motor can develop its exceptionally high torque from zero speed. Indeed, it can maintain full shaft torque from stall to full speed condition. Through some pictures, we see different examples about hydraulic drive for gear and pinion. Rotary kill friction drive. Always use this method of driving for two-tire rotary kilns, for example, FL Smith Rotax 2. Use hydraulic or mechanical drive unit for 2 rollers beside rotary kiln thrust device, at inlet of the kiln. Rotary kiln friction drive. Divided into 1. Hydraulic friction drive. Hydraulic friction drive. Use a hydraulic P2P, to rotate the roller by a hydraulic motor. Rotary kiln friction drive. 2. Mechanical friction drive. Use electric motor, and planetary gearbox. See this video about mechanical friction drive. Through some pictures we see mechanical friction drive. Thank you for watching, and I hope these courses are helpful to everyone. Subscribing to this channel Cement Industry Courses would be appreciated. Thank you.